Hey everyone, welcome back to another video. So in this video we'll be continuing our development of the Firebase security rules to make our game more secure. And before we get started, I noticed that we're referencing here playerData.val. Well, val is still accessed through a function call rather than a property, whereas key and some other things have become properties now in the new Firebase. So we're just going to go ahead and just add parentheses to the val. And this should fix any problems you have, if you are having any problems. And it'll fix like future problems as well. So save that. Now let's go ahead and take a look at the current state of our game. So I have Chrome here, and I have Firefox here. And if I open our game, it should be working just as we had last time. Now I have another Chrome tab here. Let's see what happens when we log in again through another Chrome tab. Okay, that's fine. Nothing is going through. So I guess that's not fine. When we authenticate with Firebase, whether it's anonymous or you're using another service, it's going to remember that you're authenticated in that browser. So it's just, you can think of it like YouTube, where if you log in one tab and you have your account, it's going to remember that you're logged in, even if you're in another tab. And it's the same with Firebase. So here in our Firefox window, it actually looks like they're teleporting. It's because it's the same user, right? Just they're logged in twice. So this is a security issue that we're going to fix in this episode. It actually kind of looks cool, this teleporting. If we get closer to where the other player is, it looks like it's fine. But the farther away we get, it looks like some sort of night crawler thing. So let's go to our code real quickly. If we go to the player here, when we're initializing the player, we have pretty much just one property of the player. That's the orientation. What we're going to do, we'll add another property, and we'll call it isOnline. That sounds nice. So isOnline, and we'll check when we're loading up the player world. Before we do that, we'll check to see if the player is already online. So here I'm just readjusting our orientation information. Here we go. And instead of pushing directly to orientation, we want to do it directly to the player ID, like so. So we just added a property isOnline. And over here, before we load the world, we want to check to see if the player is already online before we load the world. So how do we do that? First, we need to get a sort of snapshot of what this player's information looks like. So we'll have our Firebase reference. We'll go to the player's location. We'll go to isOnline, once, value. So here we're just retrieving the value, and then once we have the value, we'll have the isOnline data, and we can use that data. Sorry for that. We can use that data to determine if the player is online. So if isOnline.val is equal to null, or if isOnline.val is false, then it's okay to load the game. And here we can delete this load game. And we can set the player ID somewhere before here. Maybe let's just do it before we load the game. Else, so if isOnline is not null and it's true, then maybe we'll have to alert the player, hey, stop cheating, yo. Something like that. Actually, that's a little too aggressive. Let's have something less aggressive. They're not necessarily cheating. Maybe it's just they're not aware. Hey, only one session at a time, buddy. There we go. That's nicer. And yeah, so we alert them if they're trying to have 2 sessions at a time. So if we can refresh here and see what happens. So we have this first player, and the player goes in again, and that's not working. Okay, so let's see what's up. So you recall once. Right, this is bad. So player ID is actually null. So I didn't mean to put it up here. And if we refresh, hey, only 1 session at a time, buddy. And then the world doesn't load, and we can only have 1 player. That's wonderful. Okay, so we've kind of fixed that, but actually the player can still teleport. So for instance, if I open Firefox again, here, and we have in the console, we can write player, and this is something that the whoever's using your site, they can do it on the console directly. So player.mesh.position.copy new 3.vector3, and we can set this guy's position to 0, 0, 0. So we just teleported to 0, and holy crap, we teleported if you're looking from this guy's perspective. And we can do that again. Oh my goodness, he's cheating. So let's go ahead and write some security rules to prevent these sort of things. And security is really important when it comes to securing your Firebase applications. I guess that's sort of obvious to say. But your rules need to be written in such a way that secures what you want to be. Like it's sort of going to be restricting certain things, and you'll continue to refine it until there's really as few security holes as possible. And authentication is part of that. That's why we demand that the user is authenticated, even though it's anonymous. So first of all, let's have our root here. We're going to write rules in our root, and then we'll have players, right? We need, yeah, we still have our data here. So we have data, players, and then we have a list of the players with given their, this is going to be their unique ID, and then we have is online, orientation, and so on. So what do we want to do? We want to, first of all, let's make sure that if you're this user, you can't write things into this other user. So for example, you can't set this to false, like, oh, this guy is not online. And you, right now, the way our application is set up, you can do that very easily. I'll let you figure out how you can do that. You can do that, but we don't want people to update this sort of information if they're not that user. So in our rules language, how we would implement something like that, we would, I don't know why, okay, data, players, we would say something like, so for, if you're, this is the user ID child of each player, of the players, and we want to say write, you can only write if your user ID is equal to your auth ID. So publish this. So that's going to prevent reading and writing to, it's sort of like, it's preventing impersonation. So you can't impersonate another user, or yeah, by really writing to their field. You can't say like they're offline, for instance. Next, we're going to prevent this teleporting. That's a really big thing we want to stop. So to set a rule for that, orientation, we'll set a rule in orientation, and we'll say position, and our rule will be for X, Y, and Z. And this way of doing it is sort of tedious. I'm going to show you another way of doing it instead of having to write a rule for X, Y, and Z, because they're going to be the same rule. But I'll do it this way just to show you the idea. So for X, we want to say, we're going to use this validate property, and so to prevent teleporting, I think the idea is we want the absolute value of their current location. So basically the difference of their current location and their new location to be less than some value, let's say 1. So this will prevent them from like bouncing around locations if the location is greater than this value. And for this example, we'll use 1. But you can, for your game, you could use like whatever the movement speed is. Like you don't want them to be able to move faster than this. So how do we enforce this rule in our Firebase rules language? So you could remember from math that the absolute value is just 2 statements, 2 AND statements. So you have we can rewrite this as b minus a is less than 1, and it is greater than -1. So this is what we want to do. We can do this in our rules language. So first we have this part of it. So -1 is less than b minus a, and then we have this second part of it. B minus a is less than 1. So to enforce this, we can have, let's see how, so new data, this is going to be our B, dot val minus data dot val is less than 1, and so data is our previous data, new data is our new data. So new data dot val minus data dot val is greater than -1. So that's how we do absolute value. But is this secure? Let's see. We're always going to be considering, like, how can we make this more, what rules can we add to this to reinforce security. So here we're enforcing that the absolute value of the new data and the old data has to be less than 1. And let's also make sure that the new data is always a number, right? We don't want them to write strings to this field. So now we're enforcing that the new data is a number. And let's see what else. So this is pretty good for now, I think. This will be good for now. And to do this for x, we do the same thing. We enforce the same rule. And we would copy this and paste it here. I'll just do it just to show you. But really, this is tedious. You don't want to do this for x, y, z, and then you have to take position. So here, like comma, or I mean rotation. Here you have to take rotation and do the exact same thing. Instead of doing that, we can use in Firebase what's called wildcard identifiers. So we'll copy our rule here. I think I already have it copied, but just in case, we're going to delete position and rotation, like so. And we're going to have this wildcard identifier, the $, and we're going to name it something convenient, like what would this be? So this is going to identify all the strings within, oh no, definitely publish before you leave this page. That's okay. So I've fixed it here and named our field. So this $orientation type, this is just going to, this matches against all the strings that are a direct child of orientation. So I named it orientation type because it's a convenient name. It makes sense, right? Position and rotation are just orientation types. You can actually name this anything you'd like. Just name it something convenient that you might use elsewhere in your rules as well. And orientation axis, it's the same thing. This matches against all direct children of the orientation type, so in this case position, and so it's going to match against x, y, z. If we had something called banana, then it would match that as well. So orientation axis, and we have the same rule here as we had previously. Okay, so I saved those rules, and let's add one more rule. So the current state of our application, by default, read is false by default. So right now we could not do anything with our application. No one can read the information, so you wouldn't be able to see other players. This is but by default. So this line I just wrote, it's the same as just that. they're the exact same. So we actually want to allow reading if the user is authenticated. And it's important where you put these sort of rules. So I'm going to put read here to be true, but I'm putting it as a direct, as a rule to enforce for all players, for all. Let's publish this for under players. That's important. So if I placed it, if I copy this, I'll just leave that. And if I placed it here, you're going to get very different results. And in fact, I spent like hours just trying to debug my code. I thought there was something wrong with my code, but in fact, it was just that I had read here to be true rather than up here. So it's very important. Your rules are going to, whatever is evaluated as true up here at the closer to the root is going to be enforced. It's going to be it's not going to care about anything deeper in the tree. So even if this is false, for instance, because this is true up here, reading is true, then it's not going to care about what this says that reading is false. You're still going to be able to read anything that is a child of this location. So it just ignores everything after the first true in the hierarchy. But we don't want reading to be true. We want it to be true if and only if the user is authenticated. So authentication does not equal null. I think there's one more thing we should add here. So this sort of rule, this validation rule we've created here, we're going to put that in parentheses. We're going to add something else here. Because data.val, for instance, it could be null. And new data.val could be null as well. And these are null. So new data would be null if you're trying to delete this data from this access data, and data.val would be null if there's nothing in that field already. So we still want to allow someone to push data to this node if they are creating or deleting this node, whereas this sort of thing might not result in this evaluating to true. So if the data does not exist, so if not data.exists, so the data doesn't exist, we still want the person who's writing to this field to write there. So here they're trying to create something. So data.exists, it doesn't exist. So there's no data at this field, and they're trying to create some data at that field. So we want them to be able to write, or new data.exists. We want them to delete the field if they need to as well. Oh, and we'll fix this real quickly. So instead of ID, it's UID. It's the unique user ID. So publish that, and let's look at the state of our application. If we run this, we can see our player, and over here you can see our player. So looks like everything is going fine. Okay, so let's have a recap. In this video, we basically enforced some security rules so that players don't teleport, for example. The teleporting can't happen because we make sure that the old position of the player and the new position of the player, the absolute value or the difference between those values, has to be less than 1. And also, players can't impersonate other players. So in the console, for instance, you can't write data into the other player's field, because that's not that's cheating. And we enforce that rule by here. User ID has to be auth.uid. And there are many other things we could do with our application, many other security rules. I would encourage you, if you're making a more complex game, to see how you can use the rules language of Firebase to make your application more secure. So over here, security, they have great documentation on how to use their primitives, for example auth, to add security to your application. Now, it's also important that when you are writing your security rules, that you probably shouldn't share them with people outside of your organization, because then they could figure stuff out. But of course, this is just a tutorial, and I'm happy to show you guys these rules, as I wouldn't use this in a production environment, for example. I would probably add a lot more rules. But really, the first rule of Firebase security rules is don't talk about your Firebase security rules. Alright, well, that's the end of this video, and in the next video we will let's go ahead and try to host this on a website. So it's going to be like mp template 1.firebaseapp.com. Yeah, so they just take our project name .firebaseapp.com, and they also give us a free SSL certificate, so our application will be served over a secure protocol, which is really cool. And that's going to be really easy, and that'll be in the next video. Thanks for watching, guys. Bye.